Okay, let's look at some really simple functional groups. We're going to talk in this video about hydrocarbons. So, alkanes, these are the simplest organic molecules we have. And I have 3 spectra on this slide. You might want to make this full screen so you can be sure to see what I'm pointing to. But this first spectrum in the upper left is pentane. And let's draw the structure down here. Really simple molecule. To the right of that is isopentane. And then at the bottom is decane. So not a 5-carbon molecule, but a 10-carbon molecule with decane. Now notice that these molecules look very similar according to their IR. So here is, in the upper right, pentane. Note that most of this spectrum, the line tends to be towards the top in terms of the y-axis of our spectrum, and that's the percent transmittance. So for the most part, the photons of the different energies, different wave numbers that we bombard this molecule with, they pass right through and we get about 100% transmittance. But there are a few places where we get dips, and these dips are the absorbances. The absorbances that we observe in pentane are virtually the same as the absorbances we see in isopentane and decane. Well, of course they are, because pentane and isopentane and decane all have the same functional groups. They all have simple CH bonds. And if you have the same functional groups, you're going to see the same types of absorbances in the molecule. Where is that absorbance? Well, if it may be hard to see, but that number right there is 3,000 on the pentane spectrum. And if we draw a line down to pentane, all this big peak right here, which I pretty much messed up with all my writing on the spectrum, this is all just short of 3,000 wave numbers. Well, if you go back to our table in our previous discussion, anything that shows up just below 3,000 typically means these are sp3 CH bonds. And of course, pentane has lots of sp3 CH bonds. Then again, over here on isopentane also has lots of sp3 CH bonds, and what do you know, so does decane here on the bottom of the slide. Now, for our purposes, we are typically not going to interpret anything below 1,500. So you might say, oh, but Dr. Stevens, there are some differences in these peaks off on the right-hand side of the spectrum. You're right, there are. It's called the fingerprint region. But typically, they're very difficult to interpret, and we're going to leave anything out that's below 1,500 wave numbers. So that's a quick look at some really simple alkanes. Let's get fancy and add yet another functional group. And let's look at alkenes. You'll note that alkenes aren't that different. So here's pentane on the left and pent1-ene on the right. And let's draw that structure the way we're used to seeing it more. So we've added an alkene. What is it that now shows up? Well, this peak right here, pent1-ene, is pretty big. And where is that peak? On our x-axis, it is at 1643. Well, 1640 is about where carbon-carbon double bonds show up. Here we have a peak at 1640-ish, and here we have nothing at 1640. So sometimes it's just as important to look at your spectrum and notice what peaks are not there. Pentane does not have a peak at 1640. I'm going to draw it in there. Since there is no peak there, that means pentane does not contain an alkene. One other thing, notice when we look at our line, we have our line at about 3,000 wave numbers. We said these are our sp3 CHs. What do we also see? We see this new little peak just past 3,000, greater than 3,000 wave numbers. And that is a sign of sp2 CHs, which of course we see on 1-pentene. We have these hydrogens, these are hydrogens coming off of an sp2 hybridized carbon, and they show up a little bit differently. That's a different type of functional group, and so it tends to give a different identifiable peak in our IR spectrum. So do one more thing. Let's add alkynes to complete our hydrocarbon discussion. Here again is our baseline molecule, pentane. Very boring, I know, but it's just a simple hydrocarbon with sp3 CH bonds. Now when we go to an alkyne, 1-pentyne, what do we see? Alkynes, carbon-carbon triple bonds, tend to show up just below about 2,200. Now I'm not going to get this right, but that's just about, there's around 2200. And what do you know? We have a peak right there. It's at 2120. That's exactly where an alkyne should show up. Now, terminal alkynes, the ones that have this type of CH bond and sp hybridized carbon bearing a hydrogen, those tend to show up as a nice sharp peak well above 3000 wave numbers. And that's what we see. This SPCH shows up at about 3300 wave numbers, and they tend to have a nice sharp peak. So that's if you have a terminal alkyne, you should also see that CH. So these are examples of how we will see and identify different functional groups in an IR spectrum, and these are just the hydrocarbons.